In the beginning, before the first breath of a star, and before a single neuron fired in a human brain, there was only silence. Yet within that silence lay the potential for everything: galaxies, quarks, and the secret chambers of thought itself. We now peer across cosmic distances and down to the smallest quantum flickers, but one question remains as haunting as it is electrifying. Could the very act of thinking, the experience of consciousness itself, be woven into the fabric of the universe? Imagine the light of distant galaxies pouring through telescopes like messages written in an alien script. That light began its journey billions of years ago, long before Earth had oceans, long before the first cell pulsed with life. And yet here you sit, a conscious observer, turning photons into meaning. What alchemy allows mere matter to awaken, to notice, to question? Is consciousness merely a fleeting echo of electrical impulses? Or is it a fundamental property of reality, as eternal as the galaxies themselves? Classical science has long argued for a comforting simplicity. The mind, it insists, is nothing more than the brain, a grey cathedral of neurons firing in complex but ultimately mechanical patterns. In this view, thoughts are the sparks of biochemistry. Feelings are the shadows of synaptic currents. The universe is a vast, indifferent machine, and consciousness an accidental byproduct, no more essential to existence than the sound of waves against a shore. But the human spirit resists such a sterile narrative. From ancient mystics who gazed at the night sky and felt the whisper of the divine, to modern philosophers who see mind as a cornerstone of being, there has always been a suspicion that awareness is not merely an accident. Perhaps it is the universe gazing back at itself, the cosmos becoming self-aware through us. Here lies the tension that has ignited centuries of wonder and debate. Science demands evidence, measurement, the clarity of proof. Philosophy dares to ask if the very tools we use to measure might be shaped by the consciousness we seek to explain. Can an instrument built of matter ever fully capture the essence of the experiencer? Consider the quantum world, where reality itself seems to blur beneath the microscope. Particles behave like waves until observed. Probabilities collapse into certainty when measured. Some physicists recoil at the temptation to link this to mind, warning against romantic speculation. Yet the mystery lingers. Why does observation appear to matter? Does the universe need a witness to crystallize its possibilities into actualities? Or is this merely a trick of mathematics, a misdirection we cling to because we fear the abyss of not knowing? The contrast is striking. On one side, the hard edges of materialism, polished by centuries of empirical triumphs, medicine, engineering, and the decoding of DNA. On the other, the tantalizing vision that consciousness might be woven into the very tapestry of space and time. Between them stretches a landscape of questions as vast as the void between stars. Human history is a record of our restless curiosity. The same drive that built cathedrals and particle accelerators pushes us to peer beyond the veil. Each discovery only deepens the mystery. We find that matter at its most fundamental is not solid but shimmering probability, and that the brain, for all its neural intricacy, offers no final key to the subjective fire of experience. Is consciousness an emergent trick, a grand illusion conjured by billions of neurons? Or is it something older, something that predates stars and will outlast them, a field of awareness in which galaxies are merely fleeting patterns? Some traditions speak of an underlying mind, a cosmic intelligence. Modern science hesitates, demanding proof where mysticism offers revelation, yet the question refuses to be silenced. It persists like the faint hum of cosmic background radiation, an echo of creation that no distance can erase. When you close your eyes and feel the presence of your own awareness, silent, unmeasurable, undeniable, you touch a mystery deeper than any equation. The debate is not a mere intellectual exercise. It reshapes how we see ourselves. If consciousness is only chemistry, then we are clever machines, fragile sparks destined to fade. But if awareness is fundamental, if mind is a basic ingredient of reality, then our thoughts and dreams are not accidents. They are the universe thinking itself, fragments of an infinite mind exploring its own depths. From the earliest Upanishads to the writings of Descartes, from Einstein's musings to the paradoxes of quantum theory, the dialogue continues. Every breakthrough in physics seems to open another door, and every philosophical insight reveals another layer of mystery. The cosmos is not only larger than we imagine, it may be more conscious than we dare believe. This is the question that binds mind and universe, not merely whether consciousness exists, but what it means to be aware in a universe that might itself be aware. A question as old as wonder itself, and as new as the next flicker of thought. Foundations of quantum reality, from atoms to uncertainty, long before the word quantum ignited the imagination of scientists and philosophers, the universe seemed serenely mechanical. The cosmos was a vast clockwork, every gear turning with a precision that invited prediction. Newton's laws reigned like natural scripture. If you knew the forces and the initial conditions, the future could be computed with mathematical certainty. Laplace, the French mathematician, even dreamed of an intellect, his famous demon, that knowing every particle's position and momentum could foresee every event to come. The world, in this classical vision, was a grand equation waiting to be solved, but at the dawn of the 20th century, cracks appeared in that seemingly flawless machine. The first hairline fractures came from the faint glow of a blackbody and the strange colors emitted by heated gases. Max Planck, wrestling with these anomalies, proposed something radical in 1900. Energy, he suggested, did not flow in a smooth continuum but in discrete packets, quanta. At first, it was a desperate mathematical fix, a clever trick to match experiments. Yet, this quantum was the seed of a revolution. Only a few years later, Albert Einstein deepened the heresy. In 1905, explaining the photoelectric effect, he treated light not merely as a wave, but as a stream of particle photons, each carrying a quantized punch of energy. Light, once the very emblem of continuous waves, now wore a double mask. It could ripple like a fluid disturbance, yet strike like a hail of bullets. This wave-particle duality would soon become the riddle at the heart of physics, an unsettling reminder that nature's fabric was more ambiguous than the old equations allowed. Louis de Broglie extended the strangeness further. If light could act like a particle, might matter itself behave like a wave? His bold conjecture found stunning confirmation when electrons, fired through thin crystals, produced diffraction patterns, the signature of waves interfering with themselves. Matter, it turned out, carried a hidden rhythm, a wavelength tied to its momentum. The solid world of atoms was no longer a collection of billiard balls. It shimmered with undulating possibilities. These discoveries demanded a new mathematical language. Out of the fevered debates of the 1920s emerged quantum mechanics. Werner Heisenberg's matrix formulation and Erwin Schrödinger's wave equation described electrons not as pinpointed marbles but as probability clouds, wave functions encoding the likelihood of finding a particle in a given place. The old dream of knowing both position and momentum with arbitrary precision collapsed under Heisenberg's own uncertainty principle. The more precisely you measure one, the more the other slips into indeterminacy. Nature was not merely hiding details from us. It seemed to lack them until we looked. This was more than a technical inconvenience. It shook the philosophical pillars of science. Was reality itself indeterminate, its future not a path, but a haze of probabilities? Or did quantum mechanics merely reflect our limited knowledge, a statistical veil covering a deeper, deterministic order? No figures embodied this tension more vividly than Niels Bohr and Albert Einstein. Bohr, architect of the Copenhagen interpretation, embraced the mystery. To him, the wave function did not describe an independent reality, but the information available to an observer. Measurement was not passive discovery. It was active creation, a collapse of potentialities into a single outcome. For Bohr, asking what an electron is doing when unobserved was a meaningless question like asking the color of a melody. Einstein bristled at this philosophical retreat. "God does not play dice," he famously quipped, refusing to believe that the universe was built on chance. With Boris Podolsky and Nathan Rosen, he crafted the EPR paradox, arguing that quantum mechanics must be incomplete. If two particles could be entangled so that a measurement on one instantly determined the state of the other, even across vast distances, then either hidden variables preserved determinism or information traveled faster than light, violating relativity. Bohr countered that Einstein's thought experiment only revealed quantum theory's strange but self-consistent logic. Decades later, experiments testing Bell's inequalities vindicated Bohr. Entangled particles do exhibit correlations that defy any local hidden variable theory. The universe, at its most fundamental level, behaves as if separateness is an illusion. Wave-particle duality, superposition, entanglement. These are not poetic metaphors, but experimentally verified facts. Yet their implications sound almost metaphysical. Particles exist in overlapping possibilities until observation crystallizes one reality. Two electrons can share a single quantum state so intimately that distance loses meaning. The cosmos, once conceived as a collection of independent objects, now seems like a web of relationships where information and existence blur. Such revelations do not merely rewrite physics. They challenge our intuitions about what it means to be. If matter itself cannot be pinned down without the act of measurement, what does that say about the boundary between the observer and the observed? Does consciousness merely witness the unfolding of probabilities, or does it somehow participate in choosing among them? The early quantum pioneers left these questions provocatively open. Schrödinger's famous cat, both alive and dead, until someone looks, remains the emblem of this unsettling frontier. The cat's ambiguous fate dramatizes the unresolved tension between the microscopic rules of quantum mechanics and the macroscopic world of our daily experience. As the 20th century wore on, quantum theory proved astonishingly accurate in predicting experiments, giving rise to technologies from lasers to semiconductors. Yet its philosophical enigmas never faded. The universe, once a clockwork of certainty, had revealed a deeper stratum where chance and connection reign, where the very act of asking a question may help shape the answer. The enigma of consciousness, science's greatest puzzle. What is it that peers out through your eyes at this very moment, sensing light and shadow, weaving sound into meaning, and transforming raw sensation into the feeling of a self? The question is ancient, yet it strikes with undiminished force. Consciousness, the silent witness of every thought and every heartbeat, the intangible I that surveys the world and knows it exists. We can measure the activity of neurons in a living brain with exquisite precision, yet the raw presence of awareness itself, the sheer fact that there is something it feels like to be you, remains beyond the reach of instruments. From the earliest days of philosophy, thinkers have wrestled with this riddle. 17th century René Descartes declared, "I think therefore I am," drawing a line between the mechanical body and the thinking mind. To Descartes, the essence of being was the capacity to doubt, to reflect, to be conscious. He imagined a dual realm, a physical machine of flesh and bone and an immaterial soul of thought. This vision would shape centuries of debate, casting the mind as a ghostly presence that science could not grasp. Yet even in Descartes' time, whispers of skepticism arose. Could the mind truly float free of matter? Or was it instead an emergent property of the very substance he called mere extension? The centuries that followed brought dazzling progress in understanding the machinery of life. The microscope unveiled the cell. Chemistry revealed the dance of molecules. Electricity exposed the firing of neurons. By the late 19th century, a new materialist confidence began to rise, perhaps consciousness, too, was nothing more than matter in motion, a pattern of electrochemical signals that gave birth to thought as easily as a river carves a valley. This bold promise still echoes through modern neuroscience, where functional MRI scans capture brain regions lighting up when we dream, decide, or remember. And yet here the enigma deepens. For all the data and diagrams, the scientist can only record correlations between neural events and reported experiences. They can point to the amygdala when fear flares or the visual cortex when colors bloom, but the raw feel of crimson, the intimate spark of dread, remains stubbornly private. Philosopher Thomas Nagel famously asked, "What is it like to be a bat?" He was not seeking zoological trivia, but highlighting the unbridgeable gap between objective description and subjective experience. You may chart every nerve impulse in a bat's sonar pathways, but you will never know the alien sensation of perceiving the world through echoes. This is the so-called hard problem of consciousness, a term coined by David Chalmers. The easy problems, though they are anything but trivial, concern how the brain processes information, controls behavior, or integrates sensory inputs. The hard problem asks why any of this is accompanied by experience at all. Why is there an inner movie, a theater of awareness instead of silent computation? A computer can register data, but does it feel anything? If we built a perfect neural replica of your mind in silicon, would it be conscious or merely a brilliant automaton? Materialist theories attempt to dissolve the mystery by insisting that consciousness is simply what the brain does. According to this view, subjective experience arises from physical processes just as wetness emerges from H2O molecules or life from carbon chemistry. Yet critics argue that this analogy conceals rather than explains the phenomenon. Wetness can be described in terms of molecular bonds. Life can be traced to biological mechanisms, but the glow of awareness is not a property that can be captured by rearranging equations. It is, some argue, the one thing we know more certainly than matter itself, because it is the very medium through which we know anything at all. Others have proposed radical alternatives. Panpsychists suggest that consciousness may be a fundamental feature of the universe, like space, time, or mass, a faint glimmer present even in elementary particles, which in complex arrangements brightens into the blaze of human awareness. This idea, once dismissed as mystical fancy, has quietly re-entered serious philosophical discussion. If the mind is woven into the fabric of reality, the gap between matter and experience may not be a chasm but a continuum. In contrast, many neuroscientists pursue the integrated information theory, which quantifies consciousness as the degree of informational unity in a system. The higher the integration, the richer the experience. Others favor global workspace theory, envisioning the brain as a theater where competing signals vie for the spotlight of attention. These models illuminate mechanisms, but whether they capture the essence of awareness or merely its shadows remains a subject of spirited dispute. This tension between the measurable and the ineffable haunts the study of mind. Science thrives on what can be tested, repeated, and observed. But consciousness is the very field of observation itself. To examine it objectively is like trying to see your own eyes without a mirror. We are both the experimenters and the experiment. Our awareness is the stage upon which all evidence appears, and yet it eludes the very methods we use to probe it. Consider your own experience as you read these words. Shapes of letters strike your retina. Electrical signals surge through your optic nerve. Neurons fire in patterns learned over years of language. All of this can be mapped, modeled, and predicted. But alongside the physical process, there is the silent witness, the unmistakable sense of meaning as you grasp the flow of thought. That inner glow cannot be pinned to a single neuron, nor reduced to a chemical formula. It is, as William James once said, the stream of consciousness, unbroken, immediate, and irreducibly first person. This paradox invites both humility and wonder. Perhaps the mind is not merely a byproduct of matter, nor matter simply a stage for mind, but something more intricate, a dance of being we have only begun to glimpse. For some, this is a call to expand the scope of science, to imagine new frameworks that unite subjective and objective realms. For others, it is a reminder that certain truths may always hover beyond the reach of analysis, like a melody we can hear but never capture on a score. Across cultures and centuries, sages and poets have turned inward, exploring consciousness, not with instruments but with introspection, meditation, and art. Their insights of unity, emptiness, or cosmic mind are not easily translated into the language of physics, yet they testify to a perennial human intuition that awareness is not a trivial accident but a profound dimension of reality. Today, as quantum physics reveals a universe stranger than any classical dream, some speculate that the mysteries of mind and the mysteries of matter might be two faces of a deeper truth. The strange logic of superposition and entanglement hints at realities where observer and observed cannot be cleanly separated. Might consciousness itself be entwined with these fundamental processes? The question lingers, provocative and unresolved. Science advances, theories evolve, instruments grow ever more precise. Yet the enigma of consciousness remains like a silent star at the center of our intellectual night sky, both a beacon and a riddle. To seek its nature is to confront the deepest mystery of existence, the mystery through which all other mysteries are known. And as you sit with that thought, aware of your own awareness, you participate in the very puzzle that has defied every attempt at final explanation. Quantum mind hypotheses, from Penrose to Orr, imagine standing at the edge of known science, where the familiar rules of neurons and synapses blur into the shimmering haze of quantum possibility. Here, in the liminal space between physics and philosophy, a daring question takes root. Could the strange mechanics of the quantum world, those flickers of probability and entanglement, be the key to understanding consciousness itself? This is not merely a scientific curiosity, it is an audacious attempt to solve one of the most profound mysteries of existence. From the outset, the quest to explain consciousness has frustrated thinkers. Classical neuroscience, with its elegant models of information flow and electrochemical signaling, has mapped the brain in staggering detail. Yet the elusive nature of subjective experience, what philosopher David Chalmers calls the hard problem, remains untouched. What is it like to taste the bitterness of coffee, to feel the pulse of wonder beneath a night sky? No equation or neural network, however sophisticated, fully captures the raw texture of awareness. For some, this gap signals not merely a temporary ignorance but a deeper inadequacy in our current scientific frameworks. Enter Sir Roger Penrose, a mathematician celebrated for reshaping our understanding of black holes and the fabric of space-time. In the 1980s and early 1990s, Penrose turned his attention inward, away from cosmic singularities and toward the equally enigmatic singularity of consciousness. He proposed a radical thesis that human thought cannot be entirely explained by classical computation. According to Penrose, the human mind displays a kind of non-algorithmic creativity, a capacity for insight and understanding that transcends the logic of machines. This intuition led him to the quantum realm, where indeterminacy and non-computability reign. But Penrose's speculation needed a biological counterpart, and it found one in anesthesiologist Stuart Hameroff. Hameroff had long been fascinated by the microtubules, tiny, lattice-like structures inside the brain's neurons. These cylindrical polymers, he believed, were not mere scaffolding. They might serve as information processors at a scale small enough to flirt with quantum effects. Penrose and Hameroff joined forces, and from their collaboration emerged the orchestrated objective reduction model OR. At its heart, OR is a bold narrative of physics meeting biology. Penrose's theory of objective reduction suggested that quantum superpositions, the ghostly states in which particles exist in multiple possibilities, at once collapse, not merely by observation, but through a fundamental threshold in the fabric of spacetime itself. This collapse, he argued, is non-computable and tied to the geometry of reality. Hameroff proposed that microtubules could sustain coherent quantum states long enough for these objective reductions to influence neural processing. In other words, consciousness could arise when quantum computations inside microtubules reach a critical moment of collapse, each event creating a moment of awareness. The brain, then, is not simply a classical network of firing neurons. It is a quantum orchestra, with microtubules as its hidden instruments and consciousness as the music born of their delicate harmonies. The imagery is intoxicating. Instead of a cold mechanism of electrochemical signals, we are offered a vision of the mind as a symphony of quantum notes, with each conscious moment a fleeting intersection of matter and the fundamental fabric of the universe. For seekers of cosmic connection, OR carries a tantalizing promise that our awareness is woven into the quantum grain of reality itself, that every flicker of thought resonates with the same mystery that governs the birth of stars and the dance of subatomic particles. Yet science thrives on scrutiny, and OR has faced a chorus of skeptical voices. The central challenge is environmental decoherence. Quantum states are notoriously fragile, collapsing rapidly when exposed to thermal noise or external disturbance. The warm, wet environment of the human brain operating at roughly body temperature seems an unlikely sanctuary for sustained quantum coherence. Critics argue that any quantum effects in microtubules would vanish far too quickly to influence neuronal firing, let alone orchestrate the complex flow of thought. Mainstream neuroscientists further contend that classical explanations of consciousness, while incomplete, remain far more parsimonious. Theories based on information processing, integrated neural networks, and the emergent properties of complex systems do not require exotic physics. The brain's extraordinary capabilities, they argue, need not invoke the counterintuitive strangeness of the quantum world. To them, OR risks being a poetic distraction, an elegant metaphor disguised as a mechanism. But the debate does not end there. Quantum mind hypotheses have continued to evolve, drawing new adherents and alternative formulations. Among these is the work of physicist Henry Stapp, who envisions a more direct role for quantum processes in the mind-matter interface. Stapp builds on the interpretation of quantum mechanics known as the von Neumann-Wigner hypothesis, which suggests that consciousness plays an active role in the collapse of the quantum wave function. For Stapp, the observer is not merely a passive witness to quantum events. The act of conscious intention can influence physical outcomes. In Stapp's framework, mental effort becomes a genuine causal force, shaping the unfolding of quantum events in the brain. This is more than a metaphorical flourish. If Stapp is correct, our choices and willpower might literally guide the behavior of the physical world at the quantum level. Such a claim blurs the line between physics and metaphysics, reviving age-old philosophical debates about free will and the nature of reality. It also invites a profound rethinking of causality itself. Perhaps consciousness is not an emergent byproduct of matter, but a fundamental player in the cosmic drama. The allure of these ideas is undeniable. They hint at a universe where mind and matter are not separate domains, but entwined expressions of a deeper order. For those drawn to the mysteries of existence, such theories carry the seductive implication that human awareness is not an accident of evolution, but a participant in the very structure of the cosmos. The notion that thought might ripple through the quantum fabric, subtly influencing events, feels both thrilling and unsettling. Yet, the same criticisms that shadow OR also stalk Stapp's proposal. experimental evidence remains elusive. Quantum mechanics is already strange without assigning it the task of explaining subjective experience. Many physicists argue that importing consciousness into the quantum formalism risks confusing metaphor with measurement. Without testable predictions and empirical confirmation, these hypotheses remain, for now, in the realm of speculative philosophy. Still, it is precisely this tension between bold imagination and rigorous doubt that keeps the conversation alive. The quantum mind debate is not merely a scientific dispute, it is a mirror held up to the human yearning for meaning. On one side stands the classical vision, a brain as a magnificent biological machine, consciousness as an emergent property of countless neurons exchanging signals in a dance of electrochemical precision. On the other stands the quantum vision, a mind that resonates with the deepest laws of nature, consciousness as a fundamental feature of reality itself. The contrast is striking. Classical neuroscience offers clarity and measurable progress, a steady expansion of knowledge about neural circuits and cognitive functions. The quantum mind hypotheses, by contrast, open a door onto mystery, inviting speculation about the ultimate nature of existence. It is a debate between the comforting solidity of established science and the intoxicating possibility of a cosmos where consciousness is more than mere computation. As the 21st century unfolds, experiments in quantum biology, advances in neuroimaging, and the growing dialogue between physics and philosophy may sharpen this debate. Perhaps future discoveries will illuminate hidden quantum processes within living systems, lending unexpected support to these radical ideas. Or perhaps the quest will simply deepen our appreciation of the mind's complexity, reminding us that some questions resist easy answers. For now, the quantum mind remains an open frontier, a landscape of wonder and skepticism, of daring hypotheses and uncompromising critique. Whether these theories ultimately reveal a profound truth or stand as beautiful but flawed conjectures, they continue to challenge our understanding of what it means to be conscious in a universe still rich with mystery. And in that challenge, they fulfill a deeper purpose, keeping alive the human impulse to explore the unknown, to stretch our imagination to the very edge of reality, and to ask again and again what consciousness truly is. Reality, at the quantum scale, refuses to sit still. Particles behave like mischievous phantoms, wavering between states as if undecided about their own existence. When we reach to touch them, to measure, to know, they abruptly choose, presenting a single, concrete reality. This is the measurement problem, the riddle at the heart of quantum mechanics, a puzzle that has teased physicists and philosophers for more than a century. Is the universe a stage where events unfold independently of us, or do we, as observers, ignite the very spark that turns possibility into fact? The tale begins in the early 20th century, when a small cadre of physicists uncovered a strange truth. The mathematics of quantum theory predicts a world of probabilities. Electrons, photons, entire atoms each exist as a shimmering cloud of potential outcomes, a wave function describing where something might be, how fast it might move, and even how it might spin. This wave function evolves smoothly and predictably, obeying Schrödinger's elegant equation. Yet the moment we measure when an experimenter checks an electron's position or a detector clicks, this gentle evolution shatters. The wave function collapses, and the particle shows itself in one specific place with one specific property. But what exactly counts as a measurement? And why does the act of observation force nature's hand? This paradox was no mere technicality. It gnawed at the minds of the theory's founders. Niels Bohr and Werner Heisenberg, architects of what became known as the Copenhagen interpretation, offered a daring proposal. Quantum mechanics, they argued, does not describe an objective world in the same way classical physics does. Instead, it provides a toolkit for predicting the outcomes of experiments. Reality, in their view, is not a grand cosmic stage waiting to be surveyed. It is something more elusive, a tapestry woven only when we interact with it. The observer and the observed are entangled in a dance where the act of measurement is not passive, but constitutive. Without observation, the notion of a particle having a definite position or momentum simply does not make sense. Bohr's perspective carried a radical implication. The boundary between the quantum and the classical is not fixed by nature, but by our description. We carve up the world into measuring apparatus and system, yet the cut is arbitrary. This ambiguity is unsettling. Where precisely does the quantum haze end and the definite world begin? Is it at the level of a Geiger counter, a human eye, the conscious mind? The Copenhagen view sidestepped the question, focusing on practical predictions rather than metaphysical certainty. But sidestepping did not silence the unease. Erwin Schrödinger, who gave us the famous equation, found the implications troubling enough to craft his now legendary thought experiment. Imagine a cat sealed in a box with a vial of poison, triggered by a quantum event. Until someone opens the box, the cat's fate is governed by the wave function, a superposition of both dead and alive. According to the Copenhagen stance, the cat remains suspended in this ghostly ambiguity until an observer checks. The image is absurd, even macabre, yet it captures the enigma perfectly. When does the quantum blur crystallize into a single reality? Some thinkers, unwilling to concede that observation conjures reality, sought a different path. Hugh Everett, in the 1950s, proposed what came to be known as the many worlds interpretation. To Everett, the wave function never collapses. Instead, every possible outcome of a quantum event actually occurs, each in its own branching universe. When the cat's fate is determined, reality splits. In one branch, the cat lives. In another, it dies. We too split, each version of ourselves witnessing a different outcome. In this picture, measurement is no magical moment of creation. It is merely the observer becoming entangled with one branch of a continuously unfolding multiverse. Reality, far from shrinking to a single fact, explodes into a limitless expanse of parallel worlds. Many Worlds offers a bold escape from the observer's central role. It restores a kind of objectivity. Every outcome exists, whether or not anyone looks. Yet it also multiplies realities without mercy, demanding an infinite cosmic ledger of histories. And it leaves us pondering, if all outcomes occur, why do we experience only one? Why this branch, this version of events? The question of subjective experience lingers, even in a universe that contains every possibility. Another school of thought takes a different tack. Cubism, quantum. Bayesianism casts quantum mechanics not as a description of physical reality, but as a user's manual for personal belief. For cubists, the wave function is not an external object, but an expression of an agent's expectations. Measurement is not about collapsing a physical cloud of probabilities. It is about updating beliefs when new data arrives. The observer is not a passive witness, but an active participant in a web of subjective probabilities. In this view, the quantum world is not an impersonal machine, but a dialogue between the universe and the agents who inquire. Reality is participatory not because consciousness creates particles, but because every quantum statement is about what we believe and how we revise those beliefs when nature replies. Each of these interpretations grapples with the same stubborn facts. Quantum experiments work. They yield predictions of breathtaking accuracy. Yet beneath the mathematics lies a question science has not yet resolved. What is the nature of reality when no one looks? Is the universe a vast mechanism running on its own, or does it in some sense awaken when observed? This tension between observer and participant invites both scientific rigor and philosophical wonder. The strict empiricist recoils from giving consciousness any special status. Surely, they argue, the collapse of the wave function is simply a physical interaction, perhaps an electron hitting a detector or an atom exchanging energy with its environment. Decoherence theory supports this view, showing how quantum superpositions can appear to collapse when a system becomes entangled with countless particles in its surroundings. To many physicists, this is the practical answer. Measurement is nothing mystical, merely the inevitable loss of quantum coherence. Consciousness need not enter the equation. Yet the mystery lingers because decoherence explains how probabilities look classical, not why a single outcome is experienced. We still confront the hard edge of the measurement problem. Why this outcome, here and now, rather than the whole ghostly ensemble? Is our awareness merely riding the crest of physical processes, or does it somehow select the wave we call reality? The implications stretch beyond physics into the realm of mind and meaning. If observation plays no fundamental role, then consciousness is an epiphenomenon, a flicker in a cosmos indifferent to our gaze. But if observation is central, if the act of knowing helps shape what is known, then consciousness is not an afterthought. It is a participant in the cosmic drama, a spark through which the universe encounters itself. Philosophers have long debated whether reality exists independent of mind or is inseparable from it. The quantum measurement problem gives this debate a new empirical edge. It is no longer merely a question for armchair speculation. It is inscribed in the equations and experiments of modern physics. Whether we adopt Bohr's pragmatic mystery, Everett's endless branching, or cubism's subjective probabilities, we stand before a mirror in which science reflects back our oldest questions. What is real? Who or what makes it so? Perhaps the most unsettling possibility is that the very demand for a single, final answer is misguided. Quantum mechanics may be whispering that reality is more fluid than our categories allow, that the division between observer and observed, between mind and world, is a convenient fiction. The measurement problem endures not because physics has failed, but because it points to something deeper, the inseparability of knowledge and existence. Entanglement and the web of the universe across the silent immensity of space, where galaxies drift like ancient lanterns in a dark ocean, there exists a secret thread, invisible to our eyes and yet profound enough to challenge every intuition we hold about the nature of reality. Quantum entanglement is that thread, an unearthly connection that defies the familiar logic of distance and separation. Imagine two particles born together, perhaps in the same flicker of light, then carried apart until one resides in a laboratory on Earth while the other speeds toward the distant edge of the cosmos. And yet, when one particle is touched by observation, the other responds in perfect synchrony, as if distance were an illusion and the universe were whispering in a single breath. This phenomenon is not a poetic metaphor, but an empirical fact, etched into the annals of modern physics through decades of meticulous experimentation. The groundbreaking tests of physicists like Alan Aspect in the early 1980s transformed what was once an unsettling thought experiment into undeniable evidence. Einstein, who famously dismissed the idea as spooky action at a distance, sought comfort in the belief that hidden variables might one day explain away the mystery. But no hidden mechanism has ever emerged. Instead, every rigorous trial has deepened the enigma, closing loopholes and revealing that nature herself seems to braid distant particles into a single quantum state that cannot be unraveled by space or time. To contemplate entanglement is to confront a challenge to our most basic categories of understanding. Space and time, those steadfast pillars of classical physics, suddenly appear less like absolute frameworks and more like flexible scaffolding, subject to deeper principles we barely comprehend. Information, it seems, does not respect the speed limit imposed by light, yet neither does it travel in any ordinary sense. It is as though entangled particles share an existence that transcends separation, as though they are not merely in communication but are, in some unfathomable way, one. From the smallest scales of matter to the farthest reaches of the cosmos. This revelation reframes the universe itself. It is no longer a mere collection of isolated fragments, but a vast, shimmering web, each node resonating with distant counterparts in an unbroken whole. The image calls to mind an ancient intuition found in philosophies from every culture, the Upanishadic vision of Indra's net, where every jewel reflects all others in an infinite pattern of mutual illumination. Today, quantum physics provides a startlingly literal echo of that timeless metaphor. Yet the grandeur of this picture invites both wonder and caution. Some see in entanglement a hint of cosmic consciousness, a hidden architecture that might unite not only particles, but minds. Could human thought, emotion, or awareness be subtly entangled, forming a collective field of experience? Mystics and speculative thinkers have long entertained such possibilities, drawing parallels between quantum non-locality and the elusive bonds of empathy, intuition, or telepathy. These notions tempt the imagination with visions of a universe where consciousness itself is woven into the fabric of reality, where minds participate in a deeper unity that science has only begun to glimpse. But the disciplined voice of physics demands restraint. The evidence that entanglement extends beyond the realm of subatomic particles into the domain of human consciousness is at present non-existent. Correlations between particles are delicate and fleeting, easily disrupted by the noisy chaos of macroscopic systems. The leap from quantum experiments to the vast complexities of the human brain is not merely long. It is a canyon of scale and mechanism we cannot yet cross. To claim otherwise would be to confuse metaphor with measurement, poetry with proof. Still, the very need for such caution underscores the depth of the mystery. Why should the universe permit such a phenomenon at all? What deeper order of reality allows two particles to behave as if space and time are secondary to some more fundamental unity? Some physicists, inspired by theories of quantum information, suspect that entanglement is not a curious footnote, but the very fabric of space-time itself. In their view, the geometry of the universe, its distances, its causal structure, even the notion of locality, may emerge from networks of entanglement, like a vast tapestry whose threads of correlation give rise to the dimensions we inhabit. This idea turns the tables on our common sense. We usually imagine space as the container of all things, the grand stage upon which matter and energy dance. But what if the stage is an illusion and the dance itself, the pattern of relationships, is what truly exists? In such a vision, the universe is not a collection of things in space, but a self-organizing web of connections. Space is the shadow cast by entanglement. Time is the rhythm of those relationships unfolding. Contemplating such possibilities evokes a feeling both exhilarating and unsettling. If space and time emerge from entanglement, then what we experience as separation between stars, between minds, even between moments, may be a kind of cosmic mirage. We are, in a sense, already joined in ways we cannot see. And though science does not license mystical conclusions, it invites us to consider a universe far more intimate and interconnected than our senses suggest. The experiments that reveal these truths are almost ascetic in their precision. Photons split and sent along different paths, detectors chilled to near absolute zero, lasers tuned to improbable exactness, all to catch a fleeting signal of unity. From these careful arrangements, a quiet message emerges. The universe keeps a secret of togetherness, a quiet refusal to be entirely divided. It is a message without words, an equation without a single place to pin causality. For the human spirit, this revelation resonates beyond physics. It challenges the notion of isolation that often defines modern existence. We see ourselves as discrete individuals separated by the gulfs of personal history and private thought. Yet at the foundation of reality lies a pattern that mocks the idea of ultimate separateness. Even if our minds are not literally entangled, the cosmos suggests that division is not the final truth. We belong to a universe whose deepest laws speak in the language of connection. This recognition stirs both humility and wonder. Humility, because our cherished concepts of independence and distance falter in the face of a universe that refuses to be cut into neat, compartments. Wonder, because behind the familiar surfaces of stars and atoms, there flows a hidden harmony, an invisible web of relationships more enduring than the galaxies themselves. And so we stand at a threshold, between the rigor of science and the allure of mystery, between what can be measured and what can only be imagined. Quantum entanglement does not hand us easy answers about consciousness or the ultimate nature of reality, but it offers something perhaps more valuable, a profound question. What if the universe is not a scattering of separate things, but a single, intricate whole, its every part trembling with the echoes of all others? To live with that question is to feel the quiet gravity of connection, and to glimpse, if only for an instant, the hidden web that binds us all. The night sky has always been more than an endless vault of glittering points. For the sages of India, the thinkers of Greece, and the seekers of every age, it was a mirror of the mind, an invitation to glimpse the hidden unity of all things. Today, armed with quantum equations and particle accelerators, we return to that same mystery, though our instruments are different and our questions sharpened by mathematics. Yet, in the hush between the whir of the machines and the silent drift of galaxies, the old voices still whisper. They speak of oneness. They speak of a cosmic consciousness. And if you listen closely, their echoes resonate with the discoveries of modern science. Consider the sages of the Upanishads, the ancient texts of Vedanta. Thousands of years ago, they declared that beneath the multiplicity of forms lies Brahman, an infinite, undivided reality. The world of appearances, they said, is like waves upon an ocean, ever-changing, yet never separate from the sea. For them, the self-Atman was not a lonely island of awareness, but a spark of that boundless whole. To realize this truth was not mere philosophy, it was liberation. The seeker who grasped that Atman is Brahman found the ultimate freedom. The recognition that the knower and the known are one. Now listen to the language of quantum physics. It tells us that particles once thought distinct can become entangled, their states mysteriously linked across space and time. A measurement here instantaneously shapes a result there, as though the universe conspires to remind us that separateness is, at least in part, an illusion. The equations do not speak of Brahman, yet they reveal a connectedness that defies the classical boundaries of space. The mystics used poetry, the physicists used wave functions, but the theme of interdependence feels eerily familiar. Buddhist philosophers, too, anticipated a vision of reality that modern physics now finds oddly congenial. The doctrine of dependent origination proclaims that nothing exists in isolation. Every phenomenon arises through a web of conditions. The self, far from being a fixed essence, is a dynamic interplay of processes ever-changing, like the flicker of a flame. To awaken is to see through the mirage of a permanent I and recognize the seamless fabric of existence. When quantum theory tells us that particles do not have definite properties until observed, when it blurs the line between observer and observed, can we help but hear an echo of those ancient insights? The Buddhist spoke of emptiness. The physicist speaks of probability amplitudes. Different metaphors, different methods, yet both hint that reality is less solid than our senses suggest. Plato, standing at the dawn of Western philosophy, offered another voice in this chorus. He envisioned a realm of eternal forms perfect, unchanging ideals of which our material world is but a shadow. For Plato, mathematics was the bridge between the imperfect and the eternal, a language that could hint at the hidden order beneath appearances. 2 millennia later, physicists still rely on mathematics not just as a tool, but as a guide, trusting equations to reveal truths that elude direct perception. When Dirac followed the beauty of his equations to predict the existence of antimatter, when Einstein trusted the elegance of relativity before the evidence arrived, they were, in a sense, modern Platonists. The form of the good may not appear in their papers, but the conviction that beauty and symmetry reveal reality is unmistakable. and yet the contrast is as striking as the harmony. Ancient mystics relied on inner vision, on revelation, born of meditation and myth. Modern scientists demand reproducible evidence, measurements that can be verified by anyone, anywhere. The mystic's proof lies in the transformation of consciousness. The scientist's proof lies in the calibration of instruments. The Vedantin declares unity as a lived realization. The physicist cautiously speaks of non-local correlations. One path seeks wisdom through contemplation, the other through experiment. Where the sage dissolves the ego to encounter the absolute, the scientist brackets subjectivity to isolate objective truth. This tension between the mystical intuition of oneness and the empirical rigor of science creates a fertile space of wonder. Perhaps the parallels are coincidence, mere poetic resemblance. Perhaps quantum entanglement has nothing to do with Brahman, and the probabilistic nature of reality owes nothing to Buddhist emptiness. Yet why do these metaphors return century after century, as if the human mind, when it peers deeply enough, cannot help but see the same patterns? Is it that our cognitive architecture shapes the questions we ask and the answers we imagine? Or is there indeed a hidden unity that both sage and scientist glimpse from different angles? History offers both caution and inspiration. The medieval alchemists blurred mysticism and proto-science, and their visions often wandered into fantasy. But their intuitive grasp of transformation laid groundwork for modern chemistry. Johannes Kepler spoke of God's geometric plan and followed it to the laws of planetary motion. Newton sought the mind of the Creator through mathematics, and his Principia reads at times like scripture of a cosmic order. Again and again, the impulse to find meaning beyond the data has propelled discovery. The boundary between speculation and science has never been a wall. It has always been a threshold. In our own time, thinkers like David Bohm have dared to bridge these worlds. Bohm's notion of the implicate order suggests that the manifest universe unfolds from a deeper, enfolded reality, an idea that resonates with Vedantic visions of Brahman or the Buddhist sense of interpenetration. Yet Bohm remained a physicist. He sought models that could be tested, even as he conversed with the Dalai Lama about the nature of mind. His work reminds us that dialogue between science and spirituality need not dilute either. It can sharpen both. Consider also the rise of consciousness studies. Neuroscientists map the firing of neurons, yet the subjective glow of experience and the fact of awareness itself remains a mystery. Some philosophers propose that consciousness is fundamental, not derivative, a view that echoes ancient panpsychist and Vedantic intuitions. The so-called hard problem of consciousness mirrors, in a modern idiom, the old quest to understand the relation of mind to cosmos. Here again, the line between empirical investigation and metaphysical wonder blurs, inviting both caution and curiosity. It is tempting to romanticize these parallels, to claim that quantum physics proves the sage is right, but that would be a mistake. The equations of quantum theory are precise mathematical statements. They do not affirm or deny metaphysical doctrines. Entanglement is not a mystical union. It is a statistical correlation with no hidden teleology. To confuse metaphor with evidence is to betray the discipline that makes science powerful. And yet, to ignore the resonances is to miss something profound about the human spirit, our enduring desire to find coherence, to believe that beneath chaos lies a hidden order. Perhaps the real significance of these ancient echoes is not that they predict our science, but that they reveal a continuity of wonder. Whether in a Himalayan cave or a particle accelerator, the question is the same. What is the nature of reality and what is our place within it? The Vedantin calls it Brahman, the Buddhist speaks of emptiness, the Platonist of eternal forms, the physicist of quantum fields. Each is a metaphor striving toward the unsayable. Each is a gesture toward a mystery that refuses to be captured. As we gaze deeper into the quantum fabric, discovering particles that wink in and out of existence, fields that pervade space, and symmetries that govern the dance of matter we confront, limits not unlike those faced by the ancients. Our measurements grow ever more precise, yet the essence of being slips beyond our grasp. Like the mystics, we find that knowing is not merely accumulation of facts, but an encounter with mystery itself. The further we venture, the more the cosmos resembles a poem whose meaning lies not only in the words, but in the silence between them. And so, the conversation continues across millennia, sages and scientists, poets and physicists all leaning toward the same unfathomable horizon. Their languages differ, their methods diverge, yet their longing is one. It is the longing to understand the source of existence, to trace the pattern behind the stars, to touch the consciousness that may or may not underlie the universe. We are heirs to both traditions, the discipline of reason and the daring of intuition, and it is in their dialogue that our greatest insights are born. In the quiet, after the equations, in the pause after the chant, the mystery remains. Ancient or modern, mystical or scientific, we stand before the same enigma, the infinite made visible, the invisible made thinkable. And still, the universe invites us deeper. Counterpoints. The skeptic's challenge: the deeper the conversation about quantum consciousness travels, the more it invites not only wonder, but also rigorous opposition. For every philosopher who sees in quantum mechanics the glimmer of a cosmic mind, there stands a skeptic armed with the sharp instruments of empirical science. Their voices cut through the haze of speculation, demanding clarity where mystery tempts us to drift. To them, the grandeur of a universal consciousness is not a revelation, but a mirage beautiful, perhaps, but ultimately deceptive. Consider first the formidable challenge raised by neuroscientists who study the human brain not as a mystical receiver, but as a biological machine. They argue that quantum effects, those elusive fluctuations and superpositions that define the subatomic world, are far too fragile to survive the heat and chaos of living tissue. At the scale of neurons, the brain is warm, wet, and noisy conditions that destroy the delicate coherence required for quantum phenomena. In laboratories, even the most carefully shielded systems require near absolute zero to sustain a quantum state. By contrast, the human cortex, pulsing with blood and electrical storms, seems inhospitable to such subtleties. From this perspective, to speak of quantum computation in the mind is to confuse metaphor with mechanism. The great British physicist Max Tegmark sharpened this critique with calculations that became infamous in debates about mind and matter. He estimated the decoherence timescales within neurons and concluded they collapse into classical behavior far too quickly, trillions of times faster than neural processes themselves. If his figures hold, the brain cannot maintain quantum coherence long enough to influence cognition. In other words, quantum states would dissolve before they could do anything meaningful. To the skeptic, this single argument is nearly decisive. The fragile dance of quanta, so essential to quantum mechanics, simply cannot survive the riot of biology. Yet the challenge does not end with physics alone. Classical computation offers its own formidable explanation for consciousness, one that requires no hidden quantum dimension. Computational neuroscientists see the brain as a network of interconnected processes, each neuron a biological transistor, each synaptic pattern a computational state. Through vast parallel processing, feedback loops, and emergent dynamics, this classical machine gives rise to perception, thought, and self-awareness. For them, the mystery of consciousness is not solved by appealing to physics beyond the standard model, but by understanding how complex systems give rise to properties not present in their parts. This viewpoint finds resonance in the tradition of functionalism, the belief that what matters is not the material substrate, but the pattern of information processing. Whether implemented in carbon-based neurons or silicon chips, the argument goes, consciousness emerges from the right kind of computation. The mind in this frame is a function, not a quantum miracle. If this is true, then the seduction of quantum consciousness is unnecessary. Classical physics and classical computation are sufficient to account for every spark of awareness. Such reasoning extends beyond laboratories into philosophy's oldest caution, the danger of metaphysical inflation. Critics warn that linking quantum mechanics to mind may be less an insight than a projection, a yearning to drape the unknowable with scientific glamour. Quantum theory, with its indeterminacy and strangeness, seems to invite metaphors of mystery. But, as the philosopher of science Tim Maudlin has noted, the peculiar mathematics of wave functions does not license every poetic leap. To claim that the cosmos itself is conscious simply because quantum mechanics defies classical intuition is, for the skeptic, a category mistake. Quantum weirdness does not automatically translate into cosmic awareness. Even historical context fuels their argument. When quantum mechanics first startled the 20th century, it attracted a cultural wave of mysticism suggesting that reality itself is mind-like. But decades of experimental progress have demystified many of its puzzles. Quantum theory, once the province of paradox, now underpins lasers, semiconductors, and MRI machines. What was once mystical has become engineering. To the sober scientist, this history is a cautionary tale. Today's enigma can become tomorrow's routine. The mysterious collapse of the wave function may one day yield to an explanation as mundane as the behavior of air molecules. To stake a theory of consciousness on the enduring mystery of quantum physics is to build on sand. Moreover, skeptics point out that extraordinary claims demand extraordinary evidence. The hypothesis of cosmic consciousness is extraordinary indeed, yet where is its empirical anchor? No laboratory experiment has shown that quantum entanglement generates subjective experience, nor that superposition produces self-awareness. Our most precise quantum measurements reveal an elegant mathematical order, not the presence of mind. Without testable predictions, critics argue, the idea of quantum consciousness risks slipping into metaphysics fascinating to contemplate, but not science. This demand for falsifiability is not mere stubbornness. It is the engine of scientific progress. The skeptics are not enemies of wonder. Many are themselves captivated by the elegance of the quantum world. But they insist that awe must not replace evidence. To them, the romance of cosmic consciousness, however intoxicating, must survive the harsh light of experiment. The beauty of a theory does not guarantee its truth. Indeed, even those sympathetic to mysteries of the mind caution against the seduction of premature conclusions. Some neuroscientists who explore altered states or the hard problem of consciousness admit that we do not yet understand subjective experience. But ignorance is not licensed to invoke the quantum. To do so, they say, risks repeating the history of the god of the gaps, invoking a higher order to explain what current science cannot yet describe. For the skeptic, humility demands patience. Let neuroscience and physics advance before we declare the cosmos itself to be awake. This tension between the magnetic pull of a grand vision and the discipline of critical inquiry forms the drama at the heart of modern debates. On one side, a universe shimmering with potential consciousness. On the other, the rigor of scientists who demand proof beyond metaphor. It is a duel between the allure of transcendence and the exacting standards of empirical knowledge. Yet even as these counter-arguments mount, they do not silence the conversation. They sharpen it. For every critique of decoherence, there are questions about whether unknown mechanisms might preserve coherence in the brain. For every appeal to classical computation, there are hints of phenomena such as the binding of perception or the mystery of subjective experience that remain unexplained. The skeptic's challenge does not close the case. It defines the battlefield on which the next discoveries must unfold. Science thrives on such tension. It is the friction of competing ideas that ignites progress. In confronting the skeptics, proponents of quantum consciousness are compelled to refine their hypotheses, to devise experiments, to seek the kind of evidence that could transform speculation into knowledge. And in this crucible of debate, the quest for understanding of mind, of matter, of the universe itself becomes not weaker, but more profound. The skeptics remind us that wonder, however intoxicating, must earn its place in the ledger of truth. Their challenge is not a dismissal of mystery, but an invitation to meet the cosmos not merely with awe, but with the patient courage of inquiry. Through their scrutiny, the dream of a conscious universe, if it is to survive, must prove itself worthy of belief. Bridging the divide, emerging experiments and theories. In the hush of laboratories across the world, a quiet revolution unfolds. Here, beneath the hum of cryogenic coolers and the pulse of lasers, scientists chase whispers of a possibility that has haunted both physics and philosophy for decades. Could the strange rules of quantum mechanics be entwined with the most intimate of enigmas, the nature of human consciousness?
This is not idle speculation.
It is a field where experimental audacity meets the philosophical hunger to understand mind and matter as a single, mysterious whole. Yet for every spark of evidence there is a shadow of doubt, and for every breakthrough a limit of what current instruments can see. Researchers now dare to test what once seemed untestable. In the heart of the brain's neurons lies a lattice of delicate filaments called microtubules, slender scaffolds traditionally known for giving cells their shape and guiding their internal traffic. For decades they were biological footnotes, until physicists and neuroscientists, inspired by Roger Penrose and Stuart Hameroff, proposed something radical: that these microtubules might host coherent quantum states, flickering in and out like subatomic symphonies, and perhaps weaving the fabric of conscious experience itself. To many, the idea seemed almost heretical, a poetic metaphor stretched beyond credibility. But others recognized a daring hypothesis worth testing, a challenge to the long-standing divide between the measurable and the ineffable. Testing such a claim demands technology of almost supernatural precision. Quantum coherence is notoriously fragile. The warm, wet environment of the brain is, in theory, the last place delicate quantum states should survive. Yet biology has a way of surprising us. Recent advances in quantum biology have revealed pockets of coherence in unexpected corners of life. The uncanny efficiency of photosynthesis in plants, where excitons dance through chlorophyll with quantum agility. The navigation of migratory birds, seemingly attuned to the faint geomagnetic whisper of entangled electrons. These discoveries suggest that nature has already mastered the art of sustaining quantum effects in warm and noisy environments. If photosynthetic complexes can harbor fleeting coherence, why not the microtubules threading our neurons? Laboratories from Europe to Asia have begun the painstaking work of probing this question. Sophisticated experiments now aim lasers at isolated microtubule assemblies, measuring subtle shifts in light scattering that might betray collective quantum oscillations. Cryogenic traps hold biological samples at temperatures just above absolute zero, teasing out signals that could indicate coherence times far longer than classical physics predicts. Some teams have reported tantalizing hints, patterns of resonance and interference that defy easy classical explanation. But hints are not proof, and replication remains the stern gatekeeper of science. The promise of quantum cognition remains suspended in a realm of careful ambiguity, where each new measurement can either strengthen the case or unravel it entirely. Parallel to these direct tests of microtubules, an even broader movement examines quantum phenomena across the living world. Quantum biology, once dismissed as an exotic curiosity, is maturing into a serious discipline. Researchers explore how quantum tunneling might shape enzyme reactions, how proton transfers in DNA may influence mutation rates, and how quantum entanglement might underlie the compass sense of animals. Each discovery, though rooted in the purely biological, offers indirect encouragement to those seeking a quantum thread in consciousness. They show that life can indeed host quantum processes not as a miraculous exception, but as a subtle tool evolution has long exploited. Yet for every bold experiment, there is a sobering counterpoint. Measuring quantum states in biological systems demands apparatus that verge on the limits of physics itself. Decoherence, the swift collapse of quantum superpositions into classical certainty, acts with merciless speed. Even in controlled laboratory conditions, coherence times often last mere femtoseconds. Scaling such delicacy to the bustling chaos of the brain, where neurons fire amid constant thermal noise, stretches plausibility. Critics argue that while quantum biology may illuminate plant leaves and avian eyes, the notion of sustained quantum computation inside the human cortex may remain forever beyond reach. The tension between hope and skepticism fuels a new generation of experimental designs. Some propose implanting nanoscale sensors inside living neurons, devices sensitive enough to detect magnetic fluctuations of quantum spins. Others imagine using entangled photons to probe living tissue, seeking correlations that could betray hidden quantum pathways. There are dreams of next-generation quantum microscopes devices that could map the brain's quantum state with a fidelity as yet unimaginable. Each proposal reads like science fiction, and yet each rests on theoretical foundations firm enough to earn serious discussion in academic journals. Even more speculative are theoretical frameworks that attempt to bridge quantum mechanics and cognition, without relying solely on microtubules. Some physicists model consciousness as a form of quantum information processing, where entanglement and superposition create the raw texture of subjective experience. Others draw on the still unsettled interpretations of quantum theory itself. If the collapse of a wave function depends on observation, is the act of observation of conscious awareness already woven into the mathematics of reality? These questions blur the boundary between science and metaphysics. They invite us to reconsider what measurement truly means, and whether the mind is merely a passive witness or an active participant in the unfolding of the cosmos. Yet the path from speculation to demonstration is steep. The mathematics of quantum information is elegant, but translating it into biological plausibility demands bridging gaps across disciplines neuroscience, physics, chemistry, and philosophy. No single field can claim authority. This very difficulty becomes its own kind of lure, an intellectual frontier where certainty remains elusive. Theories compete and cross-pollinate. Decoherence models, orchestrated objective reduction, and hybrid proposals that treat consciousness as both emergent and fundamental. Each carries both the scent of possibility and the risk of collapse under the weight of empirical scrutiny. Still, the mere act of attempting these experiments reshapes the dialogue between science and philosophy. The pursuit itself signals a shift, the recognition that understanding consciousness may require tools and concepts as radical as those that first revealed the quantum world a century ago. Whether the experiments confirm or refute the presence of quantum processes in the mind, they force us to reconsider the very categories by which we define reality. The laboratory becomes not just a place of measurement, but a crucible for new metaphysical questions. For those drawn to existential mysteries, this unfolding story is more than a technical debate. It is a drama of intellect and imagination, where lasers and microtubules become symbols of a deeper quest. The yearning to know whether our thoughts are rooted only in classical matter or resonate with the deeper harmonies of the cosmos. Each paper published, each unexpected anomaly, is another turn of the plot, keeping us poised between revelation and disillusionment. As technology inches forward, quantum sensors sharpening, cryogenic techniques refining the horizon of possibility widens. The next decade may bring instruments capable of testing what today remains speculative. Perhaps we will glimpse unmistakable signatures of quantum coherence in living neurons, or perhaps we will discover with equal clarity that the brain's mysteries lie firmly within the realm of classical physics. Either outcome will transform the conversation. To confirm would rewrite our understanding of mind and matter. To refute would compel us to seek consciousness in other, perhaps even more mysterious domains. So the experiments continue, driven by both the audacity of hope and the discipline of doubt. This is the bridge between physics and philosophy, a narrow span of inquiry where evidence and wonder meet. The question of whether consciousness dances to a quantum rhythm remains open, and in that openness lies the true vitality of the search. Science, after all, thrives not only on answers, but on the courage to ask questions that strain the limits of what we can measure, and to linger in the space where mystery and reason confront one another in the flickering light of possibility. Speculative horizons. Panpsychism and the living cosmos imagine, standing beneath a night sky so clear that every star seems to burn with its own quiet intent. The darkness between those points of light is not empty. It feels charged, almost watchful. We have been taught to see the cosmos as a grand but indifferent machine. Stars forging elements, planets coalescing from dust, life arising from chemistry as an accident of probability. Yet there lingers a question that refuses to stay silent. What if the universe itself is aware? This is the bold invitation of panpsychism, a philosophical stance as old as the first metaphysicians and as contemporary as today's debates in the philosophy of mind. It proposes that consciousness is not an emergent trick of neural complexity, but a basic feature of reality itself woven into the very fabric of matter. Where physicalism argues that the universe is fundamentally composed of mindless particles obeying impersonal laws, panpsychism suggests that every particle, every field of energy carries a faint glimmer of experience. However rudimentary, the idea unsettles our tidy categories. If electrons or quarks possess even the faintest interiority, then the gulf we imagine between the living and the non-living collapses. Suddenly the cosmos ceases to be a cold backdrop and becomes a kind of vast, self-reflective organism. We would no longer be solitary minds adrift in a silent void, but local expressions of a consciousness that spans the stars. Skeptics rightly press for evidence. Traditional science thrives on measurement and falsifiability, and panpsychism resists both. How would one detect a subjective flicker in a photon or a whisper of awareness in a magnetic field? There are no instruments calibrated to register the texture of experience in a quark. Physicalists remind us that brains, with their billions of firing neurons, display patterns of information processing that simpler entities simply cannot match. To them, consciousness is the end product of a staggering evolutionary ascent, an emergent property, not a primitive ingredient. And yet the hard problem of consciousness remains stubborn. How does the dance of neurons produce the taste of strawberries or the ache of nostalgia? No equation has bridged the gap between objective process and subjective feeling. For some thinkers, panpsychism is less a flight of fancy than an attempt to dissolve that riddle. If consciousness is everywhere in some seed-like form, we need not conjure it from lifeless matter. Instead, complex organisms like us simply organize what is already there into the vivid theater of human awareness. This speculation is not without precedent. The Stoics envisioned a world soul pervading the cosmos. In the philosophies of India, from Vedanta to certain Buddhist schools, the mind is not confined to individual brains but saturates the universe. Even modern physics, though rigorously silent on metaphysical claims, has given us a picture of reality that humbles our intuitions. Quantum entanglement reveals correlations that defy classical separations. Fields ripple invisibly across space, binding distant events in subtle unity. None of this proves cosmic consciousness, but it lends a strange plausibility to the idea that the universe might be more than dead machinery. Picture. For a moment, the Milky Way not merely as a swirl of stars, but as a single vast organism, each star a neuron firing in a galactic mind. The gravitational arms become the filaments of thought, supernovae the synaptic sparks of some unimaginable cognition. This is poetry, yes, but it also serves as an experiment of imagination that asks us to reconsider what it means for something to be alive. Perhaps life, as we define it, is only one way that the universe's fundamental awareness becomes visible. Yet panpsychism is not a simple creed of mystical unity. It demands intellectual rigor. If every particle possesses a micro-experience, how do those tiny droplets of subjectivity combine into the rich, cohesive consciousness we know? This combination problem is a formidable challenge. Some philosophers propose that complex structures integrate these micro-experiences into higher-level minds, much as individual neurons give rise to a unified sense of self. Others argue that our very notion of experience may need a radical redefinition before the question can even be posed. Still, the allure of the idea persists because it resonates with a deep intuition that reality is not indifferent to itself. When we look up at a sky scattered with ancient light, something in us feels mirrored by that immensity. Perhaps our capacity for wonder is not an anomaly, but a clue, a faint recognition of kinship with a cosmos that, in some unfathomable way, is aware of its own existence, personal and existential implications. What it means for us, 1300 words. The cosmos has always been a mirror, but what if it is also a mind? This question of half invitation, half provocation, draws us toward an uncomfortable intimacy with the universe. We have spent centuries imagining ourselves as observers of a grand, indifferent expanse. Yet, if consciousness is not merely a local accident but a fundamental feature of reality, the boundary between out there and in here begins to dissolve. We are no longer standing outside the cosmic story. We are written into its very syntax. That realization carries a quiet, vertiginous power. It asks us not simply to wonder how the universe works, but to ask who or what we truly are. Consider personal identity. Our usual sense of self is like a fragile raft, floating on a river of thoughts, memories, and sensations. Neuroscience tells us that this raft is a construction of the brain, a dynamic pattern that flickers in and out of stability. Philosophy, from the Buddha to David Hume, has long suspected the same. The self is more process than object. But if consciousness is woven into the fabric of the cosmos, then the self may be more than an evolutionary convenience. Perhaps the I that speaks and wonders is not merely a neural echo, but a local eddy of something vast, a single spark in an infinite field of awareness. This possibility does not inflate the ego.
It erodes it.
For if the universe is conscious, then personal identity becomes both more profound and less permanent. We are not separate atoms of mind, but temporary windows through which the cosmos contemplates itself. In this view, death is not a vanishing into nothingness, but a closing of the window while the great sky of awareness remains. The terror of mortality softens, not because we have proven immortality, but because the very idea of a solitary, isolated self dissolves into a wider continuum. The universe does not lose us, it reabsorbs us. Yet here is the counterpoint. Science, in its quiet rigor, offers no final confirmation. Every quantum experiment, every neural scan, every cosmological model whispers caution. The evidence for a conscious universe remains elusive, a shimmer at the edge of measurement. It is precisely this tension between wonder and doubt that gives the question its philosophical force. We stand poised between two modes of knowing, the empirical, which demands proof, and the existential, which listens for meaning even when certainty is impossible. This tension reshapes our understanding of free will. If mind and cosmos are interwoven, then human agency cannot be reduced to mere chemical inevitability. But neither can it be romanticized as boundless autonomy. We are part of a larger, perhaps conscious system, and our choices may be expressions of that deeper order. Are we authors of our actions or instruments of cosmic intelligence? Perhaps both. The very question destabilizes the old dichotomies of determinism and freedom. It invites us to imagine free will not as absolute independence, but as participation in our decisions, like improvisations within a symphony whose full score we cannot see. To live with this possibility is to inhabit a paradox. We must act as though our choices matter because they do, while acknowledging that those choices may be shaped by patterns beyond our comprehension. This is not fatalism. It is a more subtle form of responsibility. If the universe is conscious, then every action becomes a gesture in an unfolding cosmic dialogue. Our moral lives are not merely social contracts. They may be the way the universe speaks to itself. Human purpose, too, acquires a new resonance. Traditional cosmology often left us adrift in a vast, indifferent void, but a cosmos suffused with mind reframes our existence. Purpose is no longer something we impose on an inert backdrop. It emerges from the very fabric of reality. We become participants in an ancient and ongoing act of self-discovery. Perhaps the drive to know, to create art and science is not merely human curiosity, but the universe awakening to its own depths. And yet humility remains essential. To claim certainty about cosmic consciousness is to mistake speculation for revelation. The true philosophical task is to dwell in the mystery, to let awe and skepticism coexist. It is here, in this fertile uncertainty, that meaning ripens. For meaning is not a final answer. It is the quality of attention we bring to the questions themselves. Mortality, in this light, is not an aberration, but a teacher. The inevitability of death sharpens the present moment into something luminous. If consciousness is fundamental, death is not annihilation, but transformation. If it is not, the urgency of our finite lives becomes even more precious. Either way, the lesson is the same: to live fully, to love deeply, to seek understanding even in the face of unknowing. Imagine standing beneath a night sky, the stars scattered like ancient runes. You are both infinitesimal and inseparable from the whole. The atoms of your body were forged in the heart of dying stars. The thoughts flickering through your mind are patterns of cosmic energy. Whether or not the universe is conscious, you are evidence of its capacity to wonder. Your very act of questioning is the cosmos reflecting on itself. This is the quiet revolution hidden in the question of cosmic consciousness. It shifts our gaze from distant galaxies to the immediacy of our own experience. We are not merely spectators of the universe, we are expressions of it. To recognize this is to walk a narrow path between science and mysticism, between the measurable and the ineffable. It is to live with curiosity unbroken by doubt, and with awe undiminished by the absence of proof. Closing reflections. The mystery endures from the very beginning of our journey. We've followed the faint trail of a question older than any civilization and more enduring than any theory. What is the universe, and what does it mean that we are able to ask? We have crossed the luminous domains of quantum mechanics and the shadowed corridors of metaphysics. We have listened to the whispers of ancient philosophers and the hard-edged declarations of modern physics. And yet after every equation is solved, after every debate is exhausted, the question remains. Science, in its elegant precision, has peeled back layer after layer of reality. It has revealed particles that flicker between existence and non-existence, waves of probability that refuse to be pinned down, and mathematical symmetries that seem almost too perfect to be accidental. Each breakthrough seems to promise that the next discovery will close the gap, that a final theory will snap the pieces into place. But the closer we draw to the heart of reality, the more it recedes, as though the cosmos delights in staying just one step ahead of our most brilliant minds. This is the paradox that both frustrates and electrifies us. For every experiment that tightens the net of understanding, there emerges a deeper riddle. We measure the spin of an electron with astonishing accuracy, only to confront the eerie dance of entanglement, a dance that seems to defy the very fabric of space and time. We chart the birth of galaxies, tracing their light back to the first trembling instant of creation. Yet we cannot say with certainty why there is something rather than nothing. And so we stand at the edge of knowledge, suspended between two truths. On one side, the clarity of scientific rigor, the methodical unveiling of patterns, the relentless pursuit of evidence. On the other, the vastness of what remains unknown territory that resists our instruments, our logic, even our language. Here speculation is not weakness but necessity, an act of imagination that reaches where measurement cannot. It is in this tension between the measurable and the mysterious that the human spirit thrives. Philosophers of old felt this same tension. Plato, gazing toward his eternal forms, sensed that reality must be more than the shadows we see. Centuries later, Kant warned that the thing in itself would always elude us, no matter how refined our reason. Today, physicists echo these ancient intuitions in the language of mathematics and experimental data. They speak of quantum fields and multiverses, of hidden dimensions and cosmic inflation. Yet behind their calculations lingers the same quiet humility, the recognition that reality is deeper, stranger, and more inexhaustible than any model can contain. We may be tempted to despair at this endless horizon. But what if the very impossibility of final answers is the source of our greatest meaning? The mystery is not a flaw in the design, it is the design. Our curiosity is the universe reflecting upon itself, consciousness peering into the mirror of existence. Each time we stretch our understanding, we participate in a cosmic dialogue, an exchange between the known and the unknowable. Consider how every advance in science has not diminished wonder, but multiplied it. When we learned that Earth is not the center of the cosmos, the night sky grew infinitely more profound. When we discovered that matter is mostly empty space, the solidity of our world became an even greater marvel. When quantum theory revealed that particles can exist in superposition, our very notion of reality expanded beyond the limits of common sense.
Knowledge does not close the mystery, it deepens it, and this deepening transforms us.
It humbles the arrogance that would reduce the universe to a solved puzzle, and it ignites the courage to keep questioning. We become travelers in an open-ended story where every revelation carries us toward new horizons. We begin to see that science and philosophy are not rivals but companions. One illuminates the how, the other probes the why. Together they remind us that truth is not a static prize but a living pursuit. There is, of course, a temptation to retreat into easy answers, whether in dogma or in the comforting belief that science will eventually reveal everything. But to embrace mystery is to resist both extremes. It is to dwell in the fertile space between certainty and chaos, where the unknown is not a threat but an invitation. This is the space where creativity flourishes, where art and physics, poetry and mathematics each lend their voice to the chorus of inquiry. Perhaps the most astonishing insight of all is that the universe has given rise to beings capable of wondering at their own origins. We are stardust that dreams, matter that contemplates the infinite. Our consciousness, fragile and brief, is nonetheless able to touch eternity through curiosity. When we gaze into the night sky or into the equations of quantum fields, we are the universe reflecting upon itself. A fleeting yet luminous expression of the very mystery we seek to understand. And so the journey does not end with a final pronouncement. It ends, instead, with a deepening of the question. The mystery endures not as a problem to be solved, but as a living presence that calls us to wonder. To be human is to stand in that presence with awe and humility, to let the silence between the stars speak as eloquently as the proofs in our books. The cosmos has no obligation to reveal its secrets, and yet it has already given us the greatest gift, the hunger to seek them. In that hunger lies our kinship with the infinite. It binds us to every thinker who has ever stared into the dark and asked why. It carries us forward, generation after generation, into the uncharted landscapes of knowledge and imagination. The mystery endures, and so does our quest, not because we believe we will reach the end, but because the act of seeking is itself the most profound expression of who we are.